Hello and welcome students. In this lecture, in this video I am going to teach you a theorem. This theorem will help us solve few more problems on inverse functions derivative, that is derivative of inverse functions. So here see y equals to f of x is a 1 onto function. This is statement of the theorem. Y equals to f of x is a 1 onto function and its inverse function is x equals to f inverse of y is defined, which is true. You know this. If a function is 1 onto function, then its inverse is defined. Further, it says if y equals to f of x, if y equals to f of x is a differentiable function of x in its domain, that is, this function you can differentiate with respect to x, as it is y equals to f of x, so you can differentiate this function with respect to x. That is why it is written it is a differentiable function of x. Then its inverse function x equals to f inverse of y is also differentiable function of y. Okay, please let us note this once again. Let us read this part once again. What are we given, students? Initially we are given that y equals to f of x is a function of x, and this is 1 onto function. Because of that, what happened? X equals to f inverse of y, which is inverse function, is defined. Further, it is said if y equals to f of x, if y equals to f of x, this function is a differentiable function of x, then automatically x equals to f inverse of y will also be differentiable function of y. Here y equals to f of x, it is differentiable function of x. Y equals to f of x is a differentiable function of x, then x equals to f inverse y will be differentiable function of y. This is one very important statement of the theorem. The next, it says and this relation is always true. See, what is the relation? The relation is when you said that y equals to f of x is a differentiable function of x, what do you actually mean? You mean that you can differentiate this with respect to x. So when you differentiate with respect to x, you will get d by dx of y. Then you said that this is also differentiable function with of y. So when you say this is differentiable function of y, you can differentiate this with respect to y. So here you will get d by dy of x. Now please look at these two. Here you are getting d by dy of x, and here you are getting d by dx of y. Okay, and there is relation between these two. What is that relation? These two are reciprocal of each other. These two are reciprocal of each other. That is what you have to see here. See, dx by dy is 1 upon dy by dx. This statement you have to remember. Dx by dy is 1 upon dy by dx, where dy by dx should not be 0, because if it is 0, then the denominator becomes 0 and this will be undefined. Okay, so we are going to take few examples to make this more clear. Let's start with here. Okay, so what I have y equals to 2x. It is y equals to f of x, and this is a differentiable function of x. So I differentiate with respect to x. I will get d by, when I differentiate with respect to x, what will I get? I will get d by dx of y equals to d by dx of 2x, and you know d by dx of 2x will be 2 is a constant out and dy by dx of x is 1, so you are getting 2. You got dy by dx as 2. Now here we have inverse function of this function x equals to y by 2. So let me differentiate. with respect to y. Remember students, here the domain is y, the independent variable is y. So you will differentiate with respect to y. So here I write differentiating with respect to y. When I differentiate this, differentiating with respect to y. Remember, here you differentiated with respect to x. So when you differentiate with respect to y, you will get d by dy of x equals to d by dy of y by 2. Now next, what will happen? D by dy of y by 2. 1 upon 2 is constant out, and you will get d by dy of y. You know what is d by dy of y? If you are differentiating y with respect to y, you get 1, as d by dx of x was 1. So you are getting 1 upon 2 into 1. The answer is 1 upon 2. So you can check here what is happening. You notice that dy by dx is 2 and dx by dy is 1 upon 2. So the relation holds true. Which relation? The relation where I said dx by dy is 1 upon dy by dx. 1 upon dy by dx. Let us take one more example. Here I have y equals to 3x plus 5. I differentiate both sides with respect to x. Differentiating with respect to x. So I will get d by dx of y equals to d by dx of 3x plus 5. So what will this get me? This will get me d by dx of 3x, which is 3 into 1. D by dx of x is 1 plus d by dx of 5, which is 0. So the answer is 3. Let's check here. Here what I will do, students, I will differentiate with respect to y, because x equals to f inverse of y. It is inverse function of the previous function. So here I will write differentiating with respect to y. I will get d by dy of x equals to d by dy of y minus 5 over 3. What will be next step? In this, I notice 1 upon 3 is constant. So 1 upon 3 is out, and you get d by dy of y minus 5. So the next step you get equal to 1 upon 3, and then bracket d by dy of y is 1 minus d by dy of 5 is 0. So you get 1 upon 3 into 1, that is 1 upon 3. So you are getting dx by dy as 1 upon 3. Once again, we notice that dx by dy is 1 upon 3, whereas dy by dx is 3. dy by dx is 3. So once again, they are reciprocal of each other. Dx by dy is 1 upon dy by dx. Let's take one more example. See here. In this, I have y equals to square root of x minus 5. I write differentiating with respect to x. When I do that, I get d by dx of y equals to d by dx of square root of x minus 7. So recognize the function. This is square root function, but it is square root of f of x. So d by dx of root x is 1 upon 2 root x. Here it is d by dx of root f of x. Composite function. So 1 upon 2 root x minus 7 into d by dx of x minus 7. So this is 1 upon 2 root x minus 7 into d by dx of x is 1 minus d by dx of 7 is 0. So finally you get 1 upon 2 root x minus 7. Got it? And what is root of x minus 7, students? Root of x minus 7 was y. It was y. So I can write this as 1 upon 2y. I am getting dy by dx as 1 upon 2y. Okay? Now this side I have inverse function of this. Okay, so what I have here on the right side of your screen is inverse function of y equals to square root of x minus 7. So here I have x equals to f inverse of y. So I write here differentiating with respect to y. So when I do that, I get d by dy of x equals to d by dy of y square plus 7, which is equal to d by dy of y square plus d by dy of 7. D by dy of y square. You are differentiating with respect to y. You are differentiating with respect to y, and recognize the function, students. It is variable raised to constant. Now you know it is what type? It is y raised to n type. So its derivative will be ny raised to n minus 1. So 2y raised to 2 minus 1. Okay, plus 0. Its derivative will be 2y, and this is your dx by dy. So what you notice? You notice that dx by dy is 2y and dy by dx is 1 upon 2y. So once again you notice that they are reciprocal of each other. So here the statement which we wrote, the theory which we wrote holds true. What is it? The theory is dx by dy is 1 upon dy by dx. Dx by dy is 1 upon dy by dx. You can even write dy by dx as 1 upon dx by dy. We will continue with this and solve few problems. Thank you.